Welcome to Everyday Mathematics. Today we continue to the second part of the 2024 Columbia University Integration B qualifying round. And in this round, we'll be looking at the remaining 14 problems. Problem 11, problem 12, problem 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So I hope as we solve these problems, you will stick around with us and follow through. Before we go into the solution to these problems, my request for you is if you haven't subscribed to our channel, please we do encourage you to subscribe to our channel. If you do like what we are doing here, we do encourage you to press on the like button, and yeah, please share. Without much ado, let's jump onto the solutions to the problem. So problem number 11 happens to be the indefinite integral of sine x minus pi over 8 times sine x times sine x plus pi over 8. So let's try to focus on these two areas. Now we know that cosine of A minus B is equals to cosine A cosine B plus sine A sine B. And cosine of A plus B is equals to cosine A cosine B minus sine A sine B. Therefore, sine A sine B is equals to cosine of A minus B minus cosine A plus B divided by 2. So this is something that we know about, right? So what that means is that our integral here becomes the integral of sine x, big brackets, cosine A minus B. If we take this to be A and this to be B, so this becomes pi over this becomes cosine of pi over 4 minus cosine A plus B is going to be cosine 2x divided by 2, right? And this becomes, we can pull a half out, so we have sine x cosine of pi over 4 is 1 over root 2 minus cosine of 2x, right? So this becomes integral of half 1 over root 2 sine of x minus sine of x cosine of 2x. Okay, so and here for those of us who may not know, is that sine of A cosine of B, or yes, is equals to sine of A plus B plus sine of A minus B over 2. So that's another identity. So if we take this to be A and this to be B, what we have is, so we have that. X cosine 2x, which is the same as a half 1 over 2 sine x minus bracket. So we have sine of A plus B, which is x plus 3x plus 2x, which is 3x. And then we have plus sine of this minus this, which is negative x divided by 2. So this is a half 1 over root 2 sine x minus a half sine 3x. So this becomes, this negative propagates out, so this comes minus, 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 we have a half sine x. Okay. So this becomes a half cosine of x plus 1 over 6 cosine of 3x minus a half cosine of x plus c. So essentially what we do have here, so now that we do have a half root 2 cosine of x plus 1 over 6 cosine of 3x plus, actually minus a half cosine of x plus c, we can re-express this as root 2 cosine of x plus a sixth cosine of 3x minus a half cosine of x plus c. So we can bunch this together so that now we do have, and then we multiply by this constant, so we do have negative 1 plus root 2 over 4 cosine of x, and this times this, we have 1 over 12 cosine of 3x plus c. So our basic integral of sine of x minus pi over 8 times sine of x times sine of x plus pi over 8 is equals to negative 1 plus root 2 over 4 cosine of x plus 1 over 12 cosine of 3x plus c. And that is our answer. So problem number 12, which is the indefinite integral of e to the x times the hyperbolic tangent of x. So this problem is interesting because hyperbolic tangent of x is the same as the hyperbolic sine of x over the hyperbolic cosine or cos of x, which is equals to ex then going to be x divided by 2 over ex plus ex. So those cancel out, and eventually you have ex times ex over ex, right? And so what happens here? What happens here is that now you have ex minus 1 over ex, right? So that if we multiply by ex over ex here, what we get is that we have ex times e to the 2x minus 1 over e to the 2x plus 1. So what do? We can become a little bit nifty here and say this is the same as e to the 2x plus 1 minus 2 over e to the 2x plus 1. So that we have e to the x bracket e to the x 2x plus 1 over e to the 2x plus 1 plus 2 over e to the 2x plus 1. Okay, so this would cancel out, so that now we have e to the x plus 2 e to the x over e to the 2x plus 1. Okay, so what we have here is we do have e to the x times twice e to the x over e to the 2x plus 1. So this is easy because this is the same as e to the x plus 2 here. What I could do is I could say let u be equal to the e to the x, so du dx is equal to e to the x, so du is ex dx, right? And what follows from there is that if we have we see that this is our du and we have a u squared there, so we have and this is the same as ex plus 2 times the arctangent of u plus c, but u equals to e to the x, so in other words the integral of e to the x times the hyperbolic tangent of x is e to the x plus twice the arctangent of e to the x plus the integration constant c. Okay, so that is our answer. Okay. So problem 13 is quite fascinating. Actually, very interesting problem, but all the same easy. So this is the same as what we can do is we can pull the tangent of x out, and we have tangent of x over tangent of x minus x, right? And this is the same as tangent of x minus x plus x over tangent of x minus x. So we can now say, okay, let's separate this like that. So this cancels, so we have now tangent of x plus x tangent of x over tangent of x minus x. Okay, so we're integrating tangent of x plus x tangent of x. We can re-express this as sine of x over cosine of x, plus this can be reorganized as over sine of x minus x cosine of x. And it's easy to see that sine is negative the derivative of cosine of x over cosine of x. And with this as well, when we differentiate the denominator, we get cosine of x minus cosine of x plus x sine of x. So in other words, the numerator is the derivative of x cosine of x over sine of x minus x cosine of x. And as we can see here, we get the negative natural logarithm of cosine of x plus natural logarithm of sine of x minus x cosine of x plus integration constant. So what we see here is the integral of the tangent squared of x over tangent of x minus x is equals to negative natural logarithm of cosine of x plus the logarithm of sine of x minus x cosine of x plus the integration constant c. And that is our answer. Okay. So on to problem number 14. The indefinite integral of 1 over x to the 4 plus 4. This can be expressed as the integral of 1 over x squared minus 2x plus 2, x squared plus 2x plus 2. So let's try and express this part into a partial fraction. We want to express that into partial fraction. So 1 over the product of x squared minus 2x plus 2, x squared plus 2x plus 2 is equivalent to x squared minus x plus 2, x plus b plus x squared plus 2x plus 2 cx plus d, such that when you combine whatever is on the right hand side, we now get 1 is equals to ax plus b x squared plus 2x plus 2 plus cx plus d x squared minus 2x plus 2. So 1 is equivalent to this times this. We have a, and then this times this. We have c x to the cube plus this times this. We have 2a plus this times this. We have plus b, this times d plus c. This plus times this. We get minus 2c, this times this, plus 2d times x squared plus 2a, this times this, plus 2b plus 2c minus 2d x, and then we have 2b plus 2d. So we see that this term is 0, this term is 0, this term is 0, and this term is 1. Okay, the constant term. We see that we have 2b plus d equals to 1, right? And then we saw that 2a plus b plus c minus d equals to 0. And then we saw 2a plus b minus 2c plus d was equal to 0. And then a plus c was also equal to 0. The cube term. So cube, x and the square term, I mean the x square and the x term were all 0. So what do we see here? We see a couple of things. One is that a is equals to negative c here, right? And what else do we see? We also want to see that b plus d equals to 1/2 here, right? And when that is the case, since this and this is equals to 0 from here, then it means that b minus d equals to 0, right? And then what else do we see? Because we also see b plus d here, which is equals to 1/2. So we are saying that 2a minus c plus 1/2 equals to 0. Now, since we see that a minus c, a is equals to negative c, from here we'll just say that 2a plus 1/2, this is from here, equals to 0. And so a is equals to negative 1/8, and c is equals to 1/8, right? And of this, we see that 2b is equals to 1/2, and b is equals to 1/4. And so using this, d is also equal to 1/4. Okay, so a is equals to negative 1/8, b is equals to 1/4, c is equals to 1/8, and d is equals to 1/4. So what do we see that? We see that 1 over x squared minus 2x plus 2, x squared plus 2x plus 2 is equal to negative 1 over 8x plus a quarter, x squared minus 2x plus 2 plus 1 over 8x plus a quarter over x squared plus 2x plus 2. So that's a good point we're at. And so this is the same as 1 over 16. And I will bring this fast. So we have 2x plus 4 over x squared plus 2x plus 2 minus 2x minus 4 x squared plus 2x plus 2. Okay. And we can try. I would want to express the numerator as a derivative of that first. So I'll have 1 over 16 2x plus 2 over x squared plus 2x plus 2, and then I will write 1 over 16 times, there's a remaining 2 there, so I have x squared, so this is a plus 2x plus 2, and we can also write here 2x. Apologies, we made a mistake somewhere, and that is this part has to be negative 2 x minus 2 over x squared minus 2x plus 2. And since we are missing something here, we're going to put plus 1 over 16 2x squared minus 2x plus 2. Okay, close bracket. And so the integral of x squared minus 2x plus 2, x squared plus 2x plus 2 is equal to the integral of 1 over 16 2x plus 2 x squared plus 2x plus 2 minus 2x minus 2 x squared minus 2x plus 2 plus 1 over 16 2x squared plus 2x plus 2 x squared minus 2x plus 2, which is equal to 1 over 16, the derivative of x squared plus 2x plus 2 minus the derivative of x squared minus 2x plus 2 over x squared minus 2x plus 2 plus 1 over 16, we'll just say 2 over x plus 1 squared plus 1 over 16 2 x minus 1 squared plus 1. Okay, so I'd like just to rewrite where we've gotten ourselves. So we have x squared plus 2x plus 2 over x squared plus 2x plus 2 plus 1 over 16, not plus but minus, okay. Two x plus 2 over x squared plus 2 minus, keep on forgetting that, yikes, 2 plus 1 over 16, 2 over x plus 1 squared plus 1 plus 1 over 16, 2 over x minus 1 squared plus 1. So from here it's easy to see that we have 1 over 16 natural logarithm of x squared plus 2x plus 2, the integral of a derivative of a function over the same function, minus 1 over 16 x squared minus 2x plus 2 plus, this is 1 over 16 actually times 2 arctangent of x plus 1 plus 2 over 16 arctangent of x minus 1 plus c, which we can express boldly as 1 over 16 log x squared plus 2x plus 2 over x squared minus 2x plus 2 plus 2 over 16, which is 1 over 8, x plus 1 plus 2 over 16 arctangent of x minus 1 plus c. So to conclude this entire thing here, very complicated, 1 over x to the 4 plus 4 dx is the same as 1 over 16 natural logarithm of x squared plus 2x plus 2 over x squared minus 2x plus 2 plus 1 over 8 arctangent of x plus 1 plus 1 over 8 arctangent of x minus 1. Let's just write that a little bit clearly. It's the integration constant. That is the answer. Next problem number 15. We're faced with a situation where we have an x squared term under the sine function. And I think it makes more sense to just say let u be equal to x squared, such that du dx is equals to 2x, and that means a half of du can be used to substitute for x dx, right? And so when x equals to 0, u is 0, and when x equals to the square root of pi over 2, u is equals to pi over 2. So this integral from 0 to square root of pi over 2, x cubed can be expressed as x squared sine x squared, and then we have x dx. So this is a du term, or half du term, sorry, is the same as from u equals to 0 to u equals to pi over 2. U is the x squared term, sine of u, so this is a half, 0, pi over 2, u sine u. And the crucial thing to note here is that sine u can be expressed as the derivative of negative cosine of u, rather. Okay. Now we're going to use, so we brought our integral to the point where we have half u from 0 to pi over 2 rather, times the derivative of the negative cosine of u du. Integration by parts is a very interesting thing that we're going to use. So we have a product of capital V and the derivative of function u. When you integrate that, you have uv minus the product of capital U and derivative of v. So our u is negative cosine u, v is u. So this is the same as negative u cos u, that is uv, 0 to pi over 2, plus this negative here, interacting with this negative here, the cosine of u, the derivative of u is going to be 1 with respect to u. We have 0 to pi over 2. So as you can see here, we have negative pi over 2 cosine of pi over 2 minus 0 times cosine of 0. All this will go to 0, and then we have plus. So we have half here from here, and we have half here. So we have half sine of u, 0 pi over 2. So we're left now with a half sine of pi over 2 minus sine of 0. So we come to sine of pi over 2 is 1, so we're left with 1 times a half, which is a half. So the important thing for us now to know is that the integral from 0 to the square root of pi over 2 of x cubed sine x squared is 1 over 2. Okay. Problem number 16 is actually very interesting. The definite integral from x equals to 0 to x equals to pi over 2 of the natural logarithm of sine x. Now, it's from the very go, I like to just state that, yes, some people like to write natural logarithm as ln of x. In this instance, I'm going to say that's the same as log of x. So that is where I'm going to start from, just so that we're on the same page. I'd like to see what the natural logarithm of cosine of x and integrated would be. So I'll just say let u be equal to x minus pi over 2. And what that means is that du dx is equals to 1. And that means du can be substituted for dx. And so when x equals to 0, u will be equal to pi over negative pi over 2. When x equals to pi over 2, u would be equal to 0. So 0 to pi over 2, natural logarithm, or let's just use that since we've decided to go that way, is equal to, in the u domain, negative pi over 2 to 0 log of sine of u plus pi over 2 du. So what is this? This is sine u cosine pi over 2 plus sine pi over 2 cosine u. So it's the same as cosine of u. Okay. So with that in mind, we pi over 2, 0 cosine of u. So if we let u to be negative, so we're going to get pi over 2. du is going to be negative, so everything is going to be cosine of negative u is just going to be cosine u. That's the beauty of cosine. Doesn't really depend on the sign. And then this sign here allows us to flip the limits. So in other words, the important thing to know here is equals to that's one thing we were just trying to prove. So what does that mean is that if let's delete that for now and say okay, we're saying if I, capital I, is 0 to pi over 2 log of sine of x, which is equals to 0 to pi over 2 cosine of x, then it means that 2I is equals to 0 pi over 2 log sine of x plus 0 pi over 2 log cosine of x, which means that this is 0 pi over 2 log of sine of x plus log of cosine of x. So rules of logarithm means that we can now multiply whatever is in there under the log function. So we have sine of x times cosine of x under the log function integrated. So we have 2I is equals to integral from 0 to pi over 2 log of sine of x times cosine of x. Right? Then we could also say that this is 0 to pi over 2 log of a half times 2 sine x cosine of x dx, which is the same as 0 to pi over 2. We can decouple off half plus 0 pi over 2 log of 2. Let's just delete that. Writing too fast doesn't help. Twice sine of x cosine of x dx. So which is the same as negative 0 pi over 2 log of 2 plus 0 pi over 2 of sine of 2x. Okay. So 2I is equals to negative log 2 0 pi over 2 dx plus 0 pi over 2 log of sine of 2x. Okay. So here we see that this is just going to be equal to log of 2 x 0 pi over 2 0 pi over 2 log of sine of 2x, which is negative pi over 2 log of 2 plus 0 pi over 2 log of sine of 2x. You can say let u be equal to 2x so if u equals to 2x, that means that du half of du is equals to dx. It's just an important fact. When x equals to 0, u is 0, x equals to pi over 2, u is equals to 2 pi, to pi rather, sorry. Okay, so let's focus on this guy here. So 0 pi over 2 logs sine 2x is equals to 0 pi log sine of u okay, which is the same as a half of integral from 0 to pi over 2 log of sine of u plus pi over 2 to pi log of sine of u. So we're at a point where we're saying sine of 2x is equals to a half 0 pi over 2 log of sine of u plus a half 0 pi over pi over 2 to pi log of sine of u. So when we, this guy here, when we bring back, say, let's say let y equals to u minus pi over 2, this integral becomes a half log of sine of u plus a half pi over 2 minus pi over 2 is 0, pi minus pi over 2 is pi over 2, log of u is y plus pi over 2 sine y plus pi over 2 dy. So as you can see, this already goes to cosine of y, right? Sine y plus times cosine pi over 2 plus sine pi over 2 times cosine y. Yep. So what we've learned here is that integral from 0 to pi over 2 log of sine of 2x dx is equals to a half integral from 0 to pi over 2 of log of sine of x plus a half 0 to pi over 2 log of cosine of x. And since we saw that this is I and this is I, right? It means that half for I, this is the same as I. So our previous integral 0 pi over 2 log of sine of x was equal to pi over 2 log of 2 plus 0 pi over 2 this was twice 2i, yes, is pi over 2 log of sine of 2x. And so since this is 1i and this times 2i times 2 here, making 2i, it means that 2i is equals to 0 pi log over 2 plus this I here. So let's just, and so I is equals to negative pi over 2 log of 2. In other words, so our big integral from 0 to pi over 2 natural logarithm of sine of x is equals to negative pi over 2 natural logarithm of 2. And that is our answer. So problem number 17. The definite integral from x equals 0 to x tends to infinity of 1 over square root of x times x plus 1. So what we do, we see this part, and I think the inclination is to say let u be equal to square root of x, meaning that u squared is equals to x, and therefore 2u du dx is equals to 1, and we can now substitute for dx with 2u du. X is 0, 0 as x tends to infinity, u should also tend to infinity. And so 0, infinity 1 over x plus 1 is the same as 0, infinity 1 over u squared plus 1, 2 u du. So this and that becomes 2, 0, 1 over u squared plus 1. So this is the same as 2 arctangent of u, 0 infinity, so which is twice limit u tends to infinity arctangent of u minus limit u tends to 0 arctangent of u, sorry. So this tends to 0 and this tends to pi over 2. And what that means is that our answer is twice times pi over 2, And so what that means is integral from x equals 0 to x tends to infinity of 1 over x square root of x plus 1 is pi. And that is the answer. Next is an interesting problem, problem number 18, which is the definite integral from x equals to 0 to x equals to 1 of the square root of x minus x squared. So how do we solve this? Let's express it in the following manner. So we have negative of x squared minus x, right? And this is 0, 1, square root of negative x. Let's try to express it as a square of, so this is squared minus a quarter. This is the same as 0, 1, square root of this negative, and the negative interact, so we have positive a quarter minus x minus a half squared. So what we can say is let x minus a half be equal to a half sine theta. What means here is that dx d theta will be equal to a half cosine of theta, and therefore dx can be used to substituted by a half cosine theta d theta. So when x equals to 0, negative a half will be equal to a half sine theta, and so theta would be equal to negative pi over 2. And when x equals to 1, a half will be equal to a half sine theta, and theta would be equal to pi over 2. So what we have here, so 0, 1 square root of a quarter x is a half squared is equals to negative pi over 2 a quarter minus a quarter sine squared theta times a half cosine theta. So we can pull the half after getting the square root of a quarter out, so we have a half times this a half times the integral from negative pi over 2 to pi over 2, 1 minus sine squared theta, square root is cosine theta times cosine theta d theta, which is a quarter negative pi over 2 cosine square theta d theta, which is equals to a quarter over 2 cosine of 2 theta plus 1 over 2, which is 1 over 8 pi over 2 cosine of 2 theta plus 1, right? So we have 1 over 8 cosine of 2 theta plus 1, which is 1 over 8 a half sine 2 theta plus theta negative pi over 2 to pi over 2. So this is 1 over 16 sine 2 times cosine pi minus 1 over 16 sine of negative pi. Both of these go to 0, 0, and then we have pi over 2 obviously 1 over 8 here minus 1 over 8 pi over 2. So this is simply 1 over 8 pi or pi over 8. So in other words, the integral from 0 to 1 square root of x minus x squared is equals to pi over 8. Okay. So we have gone about a very hard way of solving problem 18, but I think there is a simpler way. And you know, it's always good to have a simple way. So one thing is, let's focus on the integrand. So if we say y is equals to square root of x minus x squared, that means that y squared should be equal to x minus x squared. So y squared plus x squared minus x equals to 0. So y squared plus x minus a half squared minus a quarter equals to 0. So y squared plus x minus a half squared is equals to a quarter. So we clearly see that we have this y minus a squared plus x minus b squared is equals to radius kind of equation, which is something of a circle. But mark you, we want a situation where everything is positive, it's above. So our circle is going to be around x equals to a half, but we're only going to take the upper loop here, and the radius is going to be equal to 1 over 2 squared, which is radius squared. So we have half here, and so area of a circle is equals to pi r squared, but we are looking at the top part only, over 2. So area is equals to pi times a half squared over 2. So area is equals to pi times a quarter over 2, which is pi over 8. And so we've integrating this guy here, in other words 0 to 1 square root of x minus x squared is equals to pi over 8. And I mean, that would have been a simpler, rather than struggling with trigonometrical substitutions. Anyway, there's always something better. So on to problem number 19. The definite integral from x equals to 0 to x equals to pi of sine to the fifth x times cosine 3x. Now, let's just focus on the indefinite, which is this. So let's say u be equal to sine of x, meaning that du dx is equals to cosine of x. And so du can be used to substitute for that, right? So if can be also represented as which is u to the fifth minus u squared du. Okay, so we have u1 minus u squared du, which is u to the fifth, u to the seventh du, meaning that u6 over minus u8 over 8 plus c. So in other words, equals to sine 6 minus sine to the power 8 plus c. So in other words, we have 0 to pi of sine to the fifth x cosine to 3x. That is sine to the sixth x over 6 minus sine to the 8th x over 8, 0, and pi. So this is obviously going to be equal to sine to the 6 pi over 6 minus sine to the 6 0 over 6 minus sine to the 8th pi over 8 minus 0 over 8. 0, 0, 0, 0, which is 0. Okay. Next is problem number 20. The definite integral from x equals to 0 to x equals to 1 of x times square root of x minus 1 over square root of x minus 1. So I think we can just say let u be equal to square root of x, and that means that u squared is equals to x. So 2u du dx is equals to 1, meaning that 2u du dx. Okay, and so when x equals to 0, u is 0. When x equals to 1, u is 1. So our problem still is from 0 to 1 of u squared times u minus 1 over u minus 1 2u du, which is 2u u cubed minus 1 over u minus 1. And I don't know, let's do some acrobatic here. U minus, yeah, let's do that. U minus 1. So u squared, we have u squared minus u squared, which is u squared minus 1. And then plus u, we have u squared minus u, which is u minus 1, plus 1, u minus 1, which is 0. So in other words, we have 2 u squared plus u plus 1 is what we have, 0 to 1, which is u to the 3 plus u squared plus u, which is 2, u to the 4th over 4 plus u to the 3 over 3 plus u squared over 2 from 0 to 1. Okay, so this means that we just have 2, 1 over 4 plus 1 over 3 plus 1 over 2 minus 0, which is 2. We have a 12 over, so plus 4 plus 6 by 2, 6. So we have 13 over 6, and that is the answer. So in other words, the nice integral from 0 to 1 of x times the square root of x minus 1 over square root of x minus 1, x is equals to 13 over 6. Okay. So problem number 21, very interesting. A definite integral from x equals -4 to x equals +4 of the absolute value of x minus 1. My absolute nested in the absolute value of that minus 1, nested absolute of that minus 1, and so on. So we have 4 ones. So the important thing for this is for me to plot this out. I know it's a linear function, but let's plot this out. So we have 1, we have 2, we have 3, we have 4. -1, -2, -3, -4. So from 0 here, I see 0 minus 1 absolute is going to be +1. +1 minus 1 is going to be 0. So we have 0. And so I'm going to start again. So 0 minus 1 absolute. And so we have a 0 at 0. And so it means that 1, I'm going to have 1. And at 2, I'm going back to 0. At 3, I'm going to 1, and so on. So -1, 2, -2, like that. So I have triangles that I have to deal with. And so this is 1, this is 2, this is 3, this is 4. And so the area here is equals to just 4 times the area of the triangle, whose base is how many units? 1, 2. So times 2, and the height is 1. So 4 is the answer of that. So problem number 22, the definite integral from x tending -infinity to x tending to +infinity of 1 over x squared plus pi x plus pi squared. This is the same as x infinity of 1 over x plus pi over 2 squared minus pi squared over 4 plus pi squared, so which is 1 over x plus pi over 2 squared plus 3 pi squared over 4. So from here I could say let x plus pi over 2 be equal to square root of 2 pi square root of 3 over 2 pi tan theta, such that dx d theta is equal to 3 over 2 pi sec squared theta. When x tends to negative infinity, this is infinity, and so in other words, tan theta tends to infinity, negative infinity, and so theta tends to negative pi over 2. When x tends to positive infinity, tan theta tends to positive infinity, and theta therefore tends to pi over 2. And so, in other words, 1 over x plus pi over 2 squared plus 3 pi squared over 4 is equals to squared over 4 tan squared theta plus 3 pi squared over 4 times over 2 pi sec, okay, which is, we can pull 3 pi over 2 out over 3 pi squared over 4 pi over 2, and so we have sec squared theta at the top, denominator we have sec squared theta d theta, and so we have 1 over root 3 over 2 pi, because this cancel, we have pi, negative pi over 2, we have theta, pi over 2 here, so which means that we have 2 and root 3 over pi minus pi over 2, which is 2 root 3 pi times pi. In other words, our beautiful integral is equals to 2 over root 3. Okay? There are two methods here that we'd like to exploit. The first one is just looking at the integrand and saying, okay, how do we integrate definite integral from x equals 0 to x equals 1 over square root of 1 minus x squared? I could say let y be equal to the square root of 1 minus x. And so notice y is a positive value here, so we have y squared is equals to 1 minus x squared, meaning that y squared plus x squared is equals to 1. So this is a circle about 0. So if we were to plot it, we have something like that. And so the radius is 1. So we have negative 1, have positive 1 here. And so we have the positive half. But we're moving from 0 to 1. So the area here is just going to be a quarter times pi, radius is 1 squared, which is pi over 4, right? So that's the simplest way to have solved it. Let's look at another way that we can solve it. We're going to use a slightly longer method here, and that one would involve substituting. So looking at x and saying let x be equal to sine theta such that dx d theta is equals to cosine of theta, and so dx can be used to substitute for cosine theta d theta, right? And so when x equals to 0, sine theta equals to 0, and so theta is 0, and x equals to 1, sine theta is equals to 1, and so theta is equals to pi over 2. So we have 0 to pi over 2 square root of 1 minus sine square theta times cosine theta d theta, which is equal to 0 to pi over 2. 1 minus sine square theta, square root is cosine theta, so cosine theta, which is equals to integral 1 over 2 cosine square theta, which is equals to 0 pi over 2 cosine 2 theta plus 1 over 2, okay, which equals to a half 0 pi over 2 cosine 2 theta plus 1, and which is a half sine 2 theta plus theta 0 pi over 2. In other words, it equals to a half sine pi minus a half sine 0 plus pi over 2 minus 0. This goes to 0. This goes to 0. This goes, well, this is 0 already. So we have a half times pi over 2, which is pi over 4. Okay. So in other words, we're back to scenario where 1 is equals to pi over 4. Okay. So both methods would work. It's up to you. Problem number 24, the definite integral from x equals to -1 to x equals to +1 of this cube of 1 plus the cube root of x. Definitely, I would like to substitute for that. I'll say let u be equal to cube root of x, meaning that u cube is equals to x, and therefore 3u squared du dx is equals to 1. So I could just say I will substitute for dx using 3u squared du. When x equals to -1, u would be equal to -1. When x equals to +1, u would be equal to +1. So in other words, -1, +1 of 1 over the cube root of x cube is equals to -1 to +1 of 1 plus u cube 3u squared. And so if I'm to use the Pascal's triangle, 1 1 1 2 1 1 3 3 1, and these are the coefficients of this expansion, I'm going to have something like that. So I have this is the same as 3, and I have 1 plus 3u plus 3u squared plus u cubed. So this is 3 u squared plus 3u cubed plus 3u to the 4 plus u to the 5th. And so this is 3 u to the 3 over 3 plus 3 over 4 u to the 4 plus 3 over 5 u to the 5 plus u to the 6 over 6, negative 1, positive 1. Now, these are even function, this and this would tend to 0 because negative 1 and positive 1 raised to these powers the same value, so when you subtract that goes off. But the important thing now is to see that here we have twice of 3, because 1 cube minus 1 cube minus negative 1 cube is going to be 2, and then we have this also is going to be 2, so we have 3 times 2 over 5. Okay, so which we can pull the 2 out so that we have 6. 6, and inside we're going to have a third plus 3 over 5. This is 6, 15, 5 plus 9, because 6, 14 over 15, by 3, 2, by 3, 5, so we're having 28 over 5. So in other words, and that is it. That's the answer.